So here's the example. We have a curve that has parametric equations x equals 5 cos t and y equals 3 sine 2t. T goes between 0 and pi over 2. Part A, find the points where the curve meets the x-axis. So that will be 2 points here and here. And generally, when we're meeting the x-axis, that always means y is going to be 0. So for these parametric equations, we want 3 sine 2t to be equal to 0 because that's y. We just solve this normally now. Now we want to take the two answers for what 2t would be equal to, and that's going to be 0 and pi. Reason being, if t is between 0 and pi over 2, that means 2t would be between 0 and pi. And on a sine graph, those are the two places where sine equals 0 in that range. So you've got 0, pi, and 2 pi, but the only two we're interested in are 0 and pi. Therefore, when we solve for t, we get t as 0 and pi over 2, both within the range. And then we're almost finished. We just need to change those into x values. So when t is 0, if we sub into the x equation now, that means x would be 5 cos 0, which equals 5. And when t is pi over 2, x would be 5 cos pi over 2, which equals 0. So on the diagram, that means that the curve meets the x-axis at 0 and 5. And the 0 is when t was equal to pi over 2. And the 5 was when t was equal to 0. I like to just make a little note there. Now we can move on to part B. Find the area between the curve and the x-axis. So this is where we're going to do our parametric integration. Now, the idea with integration normally is that we integrate y with respect to x normally. When we have parametric integration, we want to integrate with respect to t, so we need a dt there. And in order to do that, the trick is that you actually involve dx by dt in the integral. Because when you do this, the dt's effectively cancel out. So here is the parametric integration formula or method. Let me show you what that looks like in practice for part B. So we want to integrate this because we want to find the area. So we'll do y times dx dt. In this case, that's going to be the integral of y, which is 3 sine 2t, times dx dt, which we haven't found yet, so we can do that now. It will be minus 5 sine t with respect to t. You can then tidy this up. At this point, I would consider double angle formulas, specifically the one for sine 2t, which is 2 sine t cos t. And I would swap that out at this point. So make it so it's minus 30 sine squared t cos t dt. Now, once I get to this point, I'd probably go back and think about the limits. As you can see, at this point, we're integrating with respect to t. So that means we want to use the t limits. The x limits were 0 and 5, but the t limits were pi over 2 and 0 in that order. Looking at this integral we need to do, probably the best way to do it is with an integration by substitution. So let's do that on the side here. If we let u be equal to sine t, that means du dt is cos t, which means dt is du over cos t. So the integral becomes minus 30 u squared. We still have our cos t, but when we replace the dt with du over cos t, that's great because the cos t's cancel out. Now, because we are doing an integration by substitution, we have to be mindful of the limits here. So at this point, I'd change the limits to become u limits. So u is sine 0 for the top limit, which is just 0. And u is sine pi over 2 for the bottom limit, which is 1. Those in there. And then we're just now integrating minus 30 u squared with respect to u. So that's a pretty nice integration at this point. That's just minus 30 u cubed divided by 3 with the limits of 1 and 0. This is the same as just minus 10 u cubed with those limits. So then all that's left to do is to sub the limits in. And when you do that, you end up with 10 units squared for your final answer. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.